All right, I'm gonna go through how to calculate this delta H of solution from some lab data. I went ahead and ran the simulation like I showed you on a other video there, and I used sodium hydroxide and water for my solvent. And then I did 10 grams of sodium hydroxide and I did 100 grams of water, making my mass of solution 110 grams. When I did that, the simulation, we started off at 20 degrees Celsius and it showed me a final temperature of 44.18 degrees Celsius. So with that, I can find the change in temperature. Now, if I want to find delta H, what I need to do is first find Q for the solution. And that is mass times specific heat capacity times the change in temperature. So the mass is going to end up being the mass of the water, or of the solution, sorry, because that's what I'm looking for. So I'm going to use the 110 grams for the mass. The specific heat capacity, since the majority of it is water, we're going to end up just making an assumption that the specific heat capacity of the solution is 4.184. And then the change in temperature I just determined was 24.18. And when I plug that into my calculator, I got the number of joules was, looks like 11,128.6. And that's in joules. So when I do delta H, the units are always kilojoules per mole. And in this case, it's going to be the kilojoules released when the solution was being formed and the number of moles of solute. So in this case, it's going to be moles of NaOH. So I'm going to quickly convert this joules to kilojoules. That would be 11. I'll just call it 11.13 kilojoules. I just divided that by 1,000. And then for the moles of solute, I had 10 grams of NaOH. Well, the molar mass of sodium hydroxide winds up being 40 grams in 1 mole. So this is 0.25 moles. So now I can figure out what is the delta H for this solution. So I'm going to go ahead and plug that in on my calculator. So there's my number of kilojoules divided by my number of moles. And I've got my kilojoules per mole, that is delta H. All right, and you're going to do that same calculation for 2 different solids.